Okay, we're working with our 2-5 notes. On 2-5, we're going to be working with proofs. A proof is a logical argument that uses deductive or facts, deductive reasoning to show that a statement is true. We write reasons in a proof. We always have statements and then reasons. We have 2 columns. We're going to write our given. Whatever they give us, we write it in there first, and the reason for that is given. Then we can go and look from the given, look at our picture. They tell us if we add A plus AB plus AB, it would equal the whole thing. So let's go see the statements that they gave us. They tell us then if we go ahead and add segment AB plus segment BC, it would equal AC. This is our segment addition postulate. And you can look, the reason we're putting this is because of the segment addition postulate. I know if I add my AB segment plus my BC segment, it's going to equal AC, which is the whole thing. Then we go look at the next one. The next one says segment AB plus AB would equal AB plus BC. That's going to be our transitive property of equality. You're going to have to use all kinds of properties and definitions and postulates that we've already gone over this year in order to see which ones go in there. Then we have our reason for AB to equal BC. Whatever we're trying to prove always is going to go at the end. It will be the last statement. But your reason is not proof. Proof would not be the reason why. If you took this statement here on number 3 and you think of it like an equation. If I want to get rid of an AB on this side, I would subtract the AB. You will be subtracting AB out. If we subtract the ABs from both sides, we're going to be left with AB equals BC. Isn't that what we were looking for? So our reason down here would be the subtraction property. Let's go practice more on proofs. It says writing steps in a proof. 6 steps of a proof are shown. Complete the statements that corresponds to each reason. You need to prove that the angle EBA, we're trying to prove that EBA is going, the measure of it equals the measure of CBD. We're trying to prove those two to be equal. So what do we always go write first? We always go write our given in first. So we're going to go write the measure of angle 1 is equal to the measure of angle 3. And how do we know? Because it's given. They're telling us that angle 1 equals angle 3. So then if I go look over here, EBA equals adding angle 2 plus the measure of angle 3. And we know that because of our angle addition postulate. Over here, EBA now, they plugged in something different. They don't have the measure of angle 3 in there anymore. They plugged in the measure of angle 1 because up here on this first one they told me angle 1 does equal angle 3. So that is substituting. Instead of the measure of angle 3, we've now substituted the measure of angle 1 in there. Okay, so we know that EBA, they want us to fill something in here, and it tells us when we're using the commutative property. Remember, the commutative property is the same as saying A plus B equals B plus A. So we're going to have something similar to that we're going to put in here. If we have EBA, the measure of angle 2 plus the measure of angle 1 up there, if we flip those, now we're going to put in what? The measure of angle 1 plus the measure of angle 2 to make it fit with our commutative property. We know if we add angle 1 plus angle 2, it should equal which one? Angle 1 plus angle 2 should equal CBD. The measure of CBD. And that is our angle addition postulate. So the last one we're going to be transitive property, and you always put whatever you're proving always goes in that last statement. So this should be what we're trying to prove. We're proving that EBA is equal to the measure of CBD. And these are going to take some practicing to get used to them. Proofs, we already said there was a logical argument that uses deductive reasoning. What we're doing is called a two-column proofs. We're doing statements and reasons. Two-column proof right here has numbered statements with reasons that go with it in a logical order. Let's go practice some more. If we go look at our next one, we're going to write a two-column proof, and this is hard to see, but this over here should say D, and this one should be angle E up there. So let's practice this one. They give us that angle 1 is equal to angle 3, and they already have the little half circles in there. That is given. The next thing they tell us is that DBA is going to equal the measure of adding angle 2 plus angle 3. That is our angle addition postulate, because what are we doing? We're adding two angles together to equal DBA. Right here, it says substitution. And if we go look up here, they tell us angle 1 and angle 3 are equal. If instead of putting angle 3 in, I'm going to go substitute that angle 1 in right there, it equals the same thing. We can substitute that angle in using the substitution property. So now I know that if I added angle 1 plus angle 2, it's going to equal angle EBC. That's another one of our angle addition postulates. Okay, and the last one, after we go there, then so far we're saying DBA is angle 1 plus angle 2, and then EBC is angle 2 plus angle 1. So if we took out the angle parts, we would have DBA equaling EBC, and that's going to be our transitive property. Like I said, these are going to take some practice on them, but you're using, if you notice, we're using definitions over here. We're using properties and postulates. Let's go look at this next one. They tell us that T is the midpoint of SU. T is the midpoint. We know that this side and this side are equal. T is the midpoint, and our reason for that is always going to be given. And right here, the sign that should be in between there is the congruent sign. So we know that ST is congruent to TU. How do we know that? Definition of midpoint. They told us T is the midpoint, so we can use the definition of midpoint to say that those two sides are congruent. Congruent statement goes with the definition of midpoint. Now, we can say that they're equal because by definition of congruent segments. We have to put that step in there. They are congruent. They're not equal until you go and put the next part in. Now, when we go look at this, right now it says ST is equal to TU. All they've done at that point is gone and put the numbers in. ST is 7x, and TU is 3x plus 20. They've gone and put those in. What do we call it when we put something in that's equal to the same thing? We're substituting those numbers in. So that is our substitution property. Now the next one is subtraction. Then we're going to take this just like an algebraic equation and come over here, and if we were going to solve for x, the next thing we would go and do would be subtract the 3x from both sides. When we do that, we're going to be left with 4x equals 20. And they told us the subtraction property of equality, so I'm going to put 4x equals 20 right there. To go finish solving that, the last thing we would do is go and divide the 4 on both sides so we can get x equals 5. So our last step we did was the division property of equality. And those we kind of went over some in 2-4 when we were solving proofs algebraically. That solves that one. Okay, hint, when writing a proof, organize your reasoning by copying or drawing a diagram for the situation described. Identify the given and the proved statements. If you notice, once I figured out T was the midpoint, I went over here and marked both of those sides as equal. If it's the midpoint, we know that ST is going to equal TU. That's just from our definition of our midpoint. go and mark those stuff on your drawing. Go and do that stuff so that you already can be getting prepared for how you're going to solve this proof. Okay, and then over here for reflexive, it didn't put the signs in here, but I want you to go ahead and write the segment above it, and it should be congruent. And we should have already gone over these beforehand. I'm just filling these in so that you can have them, and they'll be in the right spots. It didn't carry over on my notes, and I don't know why. I'm learning some of this computer stuff, so I'm sorry about that, but I am filling them in for you now. So finish filling these in just the way that they need to be. Talks about reflexive, transitive, and symmetric properties. Now these are of segments. Then we're going to have them of the angles. So in between our angles, we need to go ahead and write the congruency statements between the angles also. I think we have one more to practice after that. Okay, we're going to prove this statement. Remember, our proof always goes in at the bottom. Okay, so if we're going to prove this right here, we write our given in first. Given goes in first. And what's the reason? Because it's given. M is the midpoint of A, B. If we know M is the midpoint, we know this side, AM, is going to be congruent to BM. And how do we know that it's going to be congruent? Definition of midpoint. After the congruency statement, we can go ahead and say that AM is equal to MB from definition of congruent segments. If I added AM plus MB, it would equal AB. That is our segment addition postulate. Okay, and up here, we already have that AM equals MB. So if I want to take out the MB and instead of MB, I'm going to replace it with AM. I am substituting AM in there. How many AMs do we have here? We have 1 and 2. So technically, if I added them together, I would have the 2 AM equals AB. That's where that is coming from. And that is distributive property, excuse me. If we're going to solve for this, I can go and divide both sides by that 2. When I do that, that's going to leave me with just AM on that side. AB divided by 2, another way to write it is 1/2 AB. That is the division property. That's how you're going to go and solve that. I realize that this seems like a lot, but it takes practice to go over these. These are little hints. These are little things that I want you to go and look at. Okay, statements. Statements are based on facts that you know or conclusions from deductive reasoning. Statements from our facts. We're always going to go and write our givens in first. Whatever you have is your given, and you'll write it first. Number of your statements will always vary. If you've noticed and go back, we all had different numbers for each one of these. The reason you're given is for the last statement. The reason you're given is for the last statement. And your reasons are always going to be definitions, postulates, or proven theorems, or properties you know that are true. It might seem like a lot and seem like it's hard to do, but you will get lots of practice on these. Don't freak out. It'll be okay. Just practice and ask questions.